So why did the eclipse suck? I mean, most people are like, oh, I hated it, I hated it. Well, that's because this is like 80%, 90% right here, and it's just going to come by there, and you missed it. Oh, sorry. Let's show that again. Let's show that again. It's like 80%, 90%. Um, it's getting darker. Well, yeah, it's getting cooler. Yeah, if you can watch the thermometer, but it's just not the same. If it's not totality, it's just not the same. And here you can watch the thermometer getting warmer, and the sky getting brighter, and it's just like, we're talking like 50% eclipse there. It's like, well, 30%, 20%. It just doesn't really. It's just not the same. Here it is with a different camera. Here it's this 1 frame per second. Whereas that previous camera, that white one there that you're looking at, that little phone there you're looking at, that was taking 1 frame every 15 seconds. That's why the eclipse only lasted like, that's a 4-minute eclipse, 15, 1, 2, 3, 4, 5, 6, about 1 second of screen time, about 15 frames of screen time. This one will be a lot longer. This one I'm filming at 1 frame per second. So 4 minutes. There, I just moved ahead in case you're getting bored. I mean, you're sitting there like at a 30% eclipse, and it's like, so what? Big deal. So I'm going to skip ahead a few times here. There, I just marked a line. So the pole and the camera are lined up due south, and it's at 1 o'clock and 45 minutes, 1:45. So that line, and then we're going to jump ahead there. We just jumped ahead. So that black blob there is 2 o'clock, and then 2:15, 2:30, 2:45. And I'm about to mark the 3 o'clock mark. When I marked it there, I just marked the 3 o'clock blob. And here comes the eclipse. And at 1 frame per second, see that white? See how it turned white there? You'll see that again. There's this weird phenomenon where the other camera, that white camera you're looking at, there it is. So this will be like 14 seconds, 15 seconds or so. Yeah, so 15 seconds of screen time played back at 15 frames per second is 225 frames. But 240 frames is exactly 4 minutes. So I'm like 10 seconds shy, or 15 seconds shy of a 4 minute. However, when I get the GoPro out and I take a real-time video, it ends up being 3 minutes and 57 seconds. But here it is again. Here comes our 15-second eclipse. There's that white. See the white? The other camera picked it up as orange, so there it goes, boom. Just goes like from 99% eclipse to 100. It's just so different. So different. The GoPro doesn't really pick up that change like that, but this camera really did. This is just a Motorola phone, and that phone there you're looking at is a Samsung phone. And they're both really old. I'm surprised they worked. Well, they didn't work. The one screwed up. Okay, so here's the GoPro at full time. Real time. And this is looking at that shadow, that hour hand. The shadow of that stick is like the hour hand. That was the original clock, by the way. Okay, we're going to jump ahead here. 3, 2, 1, jump. Okay, it didn't move much. Didn't get very dark. So we're jumping ahead a few minutes at a time. 3, 2, 1. It didn't get much darker. We're okay, 3, 2, 1, boom. Not much darker. 3, 2, 1, boom. Not much darker. Okay, we're talking like 50% eclipse here, and it's just, okay, 3, 2, 1, boom. I didn't notice it. It's like 60% eclipse, and it's just nothing. 3, 2, 1, boom. There, it's a little bit darker. I saw that. Okay, 3, 2, 1. There, I saw that was a little bit darker. Okay, we're getting like in the 80 percentiles here, 90 percentiles. Okay, we're going to jump ahead. 3, 2, 1, boom. Okay, now we're in real time again. I mean, I'm not going to do any jumps, but you can see the shadow of the moon coming in the upper right hand corner. And I saw this coming for like 10 or 20 minutes beforehand. And you can see a little bit of orange developing due south, a little bit of orange there, orangey, peachy color, sunset color. I saw the moon shadow literally coming like 10 or 20 minutes ahead of time. And I was mad at the weather forecasters because they said this storm front was coming the day after the eclipse. And I was like, oh, look. See, I have my hand, I was just pointing at it. And I was like, oh, those weather people were off by 24 hours. It's going to hit us right before the eclipse. Oh, there's the shadow. You can see the shape of it, sort of. Well, when the shadow gets over us, you can see the shape of the shadow real nice in the cloud cover. That's one good thing about the kind of cloud cover we had. We had these high altitude wispy clouds. There's the orange coming. At 6 minutes and 14 seconds, 2, 3, 4, 5. We're going to get totality. 7, 8, 9, 10. 3, 2, 1. Boom! Totality. There I set the camera down so I could look at it with my glasses, and I don't need them, so I take them off. And zoom in on that thermometer. It's probably, well, it started out 75 degrees that day. If you want to go back and do a freeze frame and expand it. And it ended up at like 63 after the eclipse. It dropped 1 or 2 degrees after the eclipse. Just like everything's on a time delay, like the hottest part of the day is afternoon. The hottest time of year is after this solstice. The coldest time in the morning is like right after sunrise. There's always a time delay. There's always like a buffer. Everything's like a thermal buffer. So it was the same with the eclipse. The temperature dropped like I think to 63. I'll show you the thermometer. It'll say 65, but it literally dropped to 63 after the eclipse passed over. And you might be able to see that if you freeze frame it and zoom in. But there's the shape of the shadow right there. And there's looking north. There's east, northeast. There's south. And it turns out, why is it white in the north? Because I'm not dead center. I'll show you on the map later. There, look at the shape of the shadow. You can see it. That's what's so interesting about this cloud cover. You can see the shape of the shadow. That's so cool. But anyway, I am literally about 25 miles right there. Let's see, it's whitish. Oh no, that's looking east, northeast, south. So if I turn the camera northwest, I'm about 25 miles from the edge of the shadow, and it looks white. It doesn't look good, you know. See, there's the shadow right there, that dipping all the way down. Southwest, we're looking there. You can see the shape of the shadow. See it, and then the northwest rather, it's whitish. South, orangey. And then the shadow, the moon shadow is like 110 miles across, maybe more. But where I'm at, I'm like 85 miles from the southern part of the shadow. I'm 25 miles from the northern part of the shadow. And it's just not that great. Sure, yeah, I got a 3-minute, 57-second eclipse, but I'm not in the dead center. I was so jealous of some of my cousins who were dead center. I was like, oh man, I should have gone to his farm. But no, this is great, because this farm was better because it was big sky country. So awesome. Big sky country. Oh, if I had known. See, in 2017, I went to Tennessee. I was like nestled between two mountains. And I didn't see it coming. I didn't see it going. And it was only 2 minutes and 22 seconds. And the shadow was only like 60 to 70 miles across. This one's 110 miles across. There's the north. Yep, that's white. Well, that's actually east. So you can see the shadow coming. It's about done here. We got about another 45 seconds. About another, let's see, 9:24, 9:25. At 9 minutes and 30 seconds on this video. Ooh, look at that. That's so nice. That's looking towards the, you know, that shadow there is probably 100 miles, maybe 90 miles. It's so huge. Because you're at 20 seconds, 9 minutes, 40 seconds. We got another like 20 some seconds left. When does it pop out? About 10 minutes and 3 seconds, I think it pops out. I think it's when I put the camera, right before I put the camera back on the roof of the car. That's when it pops out. 10, 1, 2, 3, 4. Look at that huge shadow there. 5, 6, 7, 8, 9. When I get to 14, it's done. 11, 12, 13, 14. There, it's done. I think. Yeah, I put the glasses back on, but I didn't need them. So I set the camera down, checked the thermometer. It says, I think, 65. Yeah, so it started at 6 minutes and 14 seconds. It finished about 10. That was almost 4 minutes, actually. Wow. Nah, it must have been, let's subtract 3 seconds. Yeah, it was like 3 minutes, 57 seconds the first time I added it up. But now we're going to watch the shadow disappear. It's a 110 mile wide shadow. It's oval shaped. So if you look north or south, it's not very good. But if you look west, following the shadow, it's 110 miles. That's why it's so much better. Oval, yeah, I prefer a circular one, like in just southwest of Monterrey, Mexico, is a perfectly circular shadow. And the eclipse shadow proves the Earth is round because it's the shadow turns into an oval. Oh, there's a little bit of sunset color. The shadow turns into an oval as the shadow basically falls off the rounded part of the Earth. The dead center there in Mexico, southwest of Monterey, it was perfectly circular in like 4.5 minutes, or 4 minutes and 20 some seconds. And here we had an oval. That's why looking north or south it wasn't so good, but looking east or west we're looking at like 110 mile wide or more wide shadow. And here comes, in a few seconds here, I'm going to play the fast motion one. And you might see that orange, if you look real close, you might see the orange effect from that white Samsung camera. You might see that orange effect just before totality. Whereas the Motorola, it was white. So here it comes. Boom. Look for the orange. Look for the orange. Where is it? I didn't notice it. Didn't notice it. Anyway, here you can watch the temperature climb. And if you zoom in, you might be able to see it dip to 63 degrees. You have to rewind it now. Okay, so here let me show you the maps of where I was. And you can see the oval shape of the shadow. We're in this flat country here. Here comes my, see that little 310 there? I'm just above the 0 in the 310. There. That's pretty good there. That's why it's yellow, because it's not green. Green is good. Green is where my other cousin lived, right there. And he probably got 3 minutes and 59 seconds or something. Because my mom, she got like a 2-minute one, right there, that orange one. She's on the edge of the shadow. And here's what it looked like from her place. It's just white. I said, Mom, you should have gone to the other side of the house and looked to that huge 110 mile long shadow. Okay, there's the 4-minute mark right there, dead center. That'd be great. But the best thing, there's the picture by Stefan Vetter. He's on top of a mountain. It's probably the Ozarks. I don't know where. But imagine watching that shadow across the surface of the Earth at 1,200 miles an hour. Or from the Ozarks, maybe 1,100. Maybe 1,000. But anyway, that's where I'm going next, and that's where you should go. And here it is. This is why it's going to cross the Earth so fast at 1,000 miles an hour, because it's just going to zip by like, boom, done. All right, thanks for watching, and don't forget to hit like and subscribe. Good luck.